An intuitive explanation of analog electronics. Analog electronics can seem rather complicated the way it's normally taught with complicated mathematical equations, but there are some deep intuitive principles that anyone can grasp. I will be leaning heavily on the hydraulic analogy, where a system of pumps and hoses and valves are shown to be equivalent or analogous to an electronic circuit with batteries and wires and switches. The hydraulic analogy for a battery is a pump like this one here. This is an electrically driven pump with an electric motor that runs a pump that takes an input of fluid from this hose and pumps it to the output under pressure that goes out of that hose. I will also be leaning heavily on Paul Falstad's most excellent circuit simulator program. Here's the default circuit that appears when you run the program. It shows voltages and currents. The current is shown by these moving yellow dots, and the voltage is shown by the color, green for positive, red for negative. And if we open and close this switch and observe the effect on the voltage and current tracers, it's a quite interesting demonstration. But we're going to pick a different circuit. We're going to pick a blank circuit with nothing on it, and then we will draw the components we want. For example, inputs and sources. I will add a voltage source, DC voltage source. Now I can just drag and create, there's a battery. The plus side you can see is highlighted in green, showing it has a positive voltage, and the negative side with the shorter bar is the negative input. So this is like an electrical pump that's pumping water in this direction, but there's nowhere for the water to go unless we add a few components. For example, if I draw add wire, notice it has a shortcut key here with W, so either click here or you just hit the W key, and we'll create a wire over here and a wire over there. And then we're going to put in a resistor. Again, I can just hit the key code R, and that makes this resistor. And there we have a circuit with a battery through a resistor. This is like a pump pumping through a resistance in the wire. The hydraulic analogy for a wire is just a simple hose or a pipe. The hydraulic analogy for a resistor is a constriction in the pipe that resists the flow of current. Now let's add a switch to this circuit. So again, in this case, it's S is the keyboard shortcut. And now we can open and close this switch and observe the difference. Notice that when the switch is closed, the current flows, and there's a voltage drop seen in the color coding here across the resistor. And when the switch is opened, then the high pressure or high voltage stops at the switch. Now let's add a scope with a right click here, view in new scope. And here's a plot down here that shows the voltage in green and the current in yellow. Now watch what happens when I open the switch or close the valve. The voltage drops to 0 across this resistor, and the current drops to 0. Let me close the switch or open the valve, and back and forth, and you can see it's predictable. So that completes my explanation of the hydraulic analogy for a simple electric circuit. That is, that the battery behaves like a hydraulic pump that pumps hydraulic fluid down these pipelines. The resistor behaves as a restriction in the flow that slows down the flow of the fluid. And here's a switch, open to stop the current, or closed, that's analogous to a valve that is a valve is closed when this thing looks open, and the valve is open when it's continuous. Stay tuned to my next video, which will introduce the inductor and the capacitor.